Let's spend a few minutes on indoor fan speed setup for this variable speed machine. So you want to go to settings, go down to unit configurations, go down to indoor fan settings. And in here, in this particular unit, it's variable speed. So there are 5 important pieces of information. There's a design speed setting, there's a ventilation speed setting, a heat setting, a free cool setting, and a max speed setting. So the first thing is max speed. In any machine, you always want to make sure if there's ductwork issues or building space issues, things like that, where the maximum fan speed that the machine can produce is too much air. On these smaller units, it's not a big deal, but when you get into bigger sizes, if the fan is too powerful, you could hurt the ductwork or cause damage. So you got to make sure that your maximum fan is not too much air. And if it is, then you can go in here and you can change this maximum speed down to whatever percentage you think that it should be restricted. That is going to put a cap in the machine to never allow anything to ever operate that fan higher than whatever that maximum is. So you get yourself in trouble if you set that too low and then you set these ones that are higher than that, because they won't ever actually run. So that's max speed. You want to make sure that you set that if you need to. A lot of cases you don't need to. And all this again is in the literature if you reference the indoor fan operation section. So on this variable speed, one of the most important settings is this cool design speed. This is going to be your design intent point. You go to the chart, the labels stuck on the machine. There's a reference in the literature too, it's just an example, but the ones printed on the machine are per model number, and you'll actually see the model number printed on the label itself, indicating exactly what unit that is referencing. So this cooling design, it'll be defaulted for every machine at approximately 400 CFM per ton, 1.2 inches of static. So we've tried to default it to something reasonable. It should always be set per job site, per application, but at least it'll get you something to run with until you can properly set it up with an air balancer. So on this particular machine, if it's a 5-ton, and I know my application needs 5 ton and it's say 375 CFM per ton, and I know that it's 0.7 inches of static is my application, then you go to the chart and you look up on the chart, you find the column first, which is your static, and you find your CFM on the left, and you find the table, the point which tells you the RPM for what that is. So you use the table, you find the RPM you need, you dial it in here for that point. That's going to drive the whole cooling algorithm. And so as the fan is ramping and changing for cooling purposes, it has that calibration point in mind, and it will react accordingly. So the next important piece, which is where you're going to run a lot of your time, is the ventilation speed. You can use the cooling as an indication, but in this case what you're going to say is, well, what ventilation speed gives me the best airflow using a damper? So in this case, if I have an economizer, then the economizer is going to have to open to provide ventilation, and the fan's going to have to run. So the combination of indoor fan and damper go hand in hand to minimize the power usage. And obviously the power is coming from the fan. So the lower the fan, the greater the damper, but that's going to save you the most energy. So that's where you want to find that sweet spot and figure out what RPM that fan needs to be for vent. So anytime I'm in vent, that's the fan I'm going to run. Heat speed, it's once I go into heat mode and I run heating, what speed is it you want for there? So it's dedicated now, so it doesn't have to be locked to cooling. You can have your own dedicated heat speed based on how much heat you have, based on what the load is, based on where you are. You choose now what you want your heat speed to be for best heating performance. And then the same thing with free cooling. If I'm doing free cooling, how much more air do I want to bring in than vent? I'm going to open the damper up even more. I'm going to want more fan so that way I can circulate that air, bring in that outside air. What speed do I want? And we talked about max fan speed. You know, as you're putting these in, a question may pop in your mind. How do I know if one's set higher than the other, or things like that, and does it matter, and how does it transition? Just keep in mind that per mode, no matter what, you're always going to run the higher fan speed. So in a vent situation, if you set vent too high and the cooling speed is saying something lower than what the vent speed is, then we're going to run the vent speed because that's higher, more airflow. So at any given time, it's going to run the higher of whatever the fan speed settings are. So just keep that in mind. So once you've set all those in, you can write them on a startup sheet, you can write them on the label or circle them or something on the label so that way it indicates later on in the life of this unit what the setup was and what we wanted for those fan settings.